Hello, my name is Yudy Yunardy, and this is my Capstone project for IBM Advanced Data Science. I will be presenting about predicting breast cancer patients' living status after 5 years. Okay, the use case are as follows. As we all know that the breast cancer is the most commonly occurring cancer for women and second most common cancer overall. And we see that there were over 2 million new cases in 2018. It is the fifth most common cause of death from cancer in women. It is crucial for patients to know the prognosis and estimated lifetime left. It's also crucial for doctors to be able to make right prognosis in accordance to patients' initial data. Today, the simple prognosis is usually based on the stage and age and do not consider other factors. It is possible to build a system that will make a more accurate prognosis based on all initial patient data with decent accuracy. The result from this project is 70% accuracy for patients' living status classification after 5 years. It means that it is possible to make a fully operable system capable of predicting patients' living status after a particular amount of years based only on initial medical tests. It also means that such system could be used to help doctors in making the right decisions about future treatment. And the future work suggested in this project in the direction of enlarging the dataset to make it more accurate and to achieve higher accuracy and adding additional functionality to the system. The architecture being used is IBM Watson Studio with Jupyter Notebooks in Python and Apache Spark. And the libraries used are Pandas, scikit-learn, Keras, Matplotlib, and Seaborn. Now we see the dataset being used is the breast cancer dataset from CBioportal for cancer genomics. I will have the links in the ADD documents with the targeted sequencing of 2,509 primary breast tumors. And also I will put the raw dataset in my GitHub account. I will give the link later, but you can also visit the CBioportal website. I will also include the link in this documents or in the ADD. As you would see from the dataset that there is a lot of missing values, and this is usual for real-world data. Also, there is mixed patient data, and you would see in my notebook that this data numerical features are skewed, and we will be correcting that later. And prediction classes are imbalanced. First, we will clean the data, fill the missing values, and then transform the data, split the test and train data, then one-hot encoding, scaling the data, and join them. In cleaning the data, I also dropped the unnecessary column in order to increase the performance of the model. And here we see that the right side is the result of the clean data or just the necessary fields to build the model. Here I tried 3 alternatives to fill the missing values. First, by dropping the columns. For example, if we drop the tumor stage column, we could get rid of around 400 missing values from that column, and in result we would get about 1758 rows. And if we drop all the nuns, we will get 1120 rows, and this is too small compared to other alternatives. Last alternative is impute the features with random forest, and we will get 1825 rows. We will transform the data with the log x plus 1. This transformation is often used for the transforming the data that are skewed and also include zero values in it. Here we see that the left side is the original data and the right is the transform with the log. We will see the data is not skewed, at least not too skewed anymore. Okay, and then the data set will be splitting into the train and test data. Okay, this is one hot encoding, and for a refresher, one hot encoding is in digital circuits and machine learning is a group of bits among which the legal combination of values are only those with the single high bit and the others are low, or usually that only single one value and the rest is zero. Okay. Feature scaling is the method used to normalize, in this case to normalize the range of independent variables or feature of the data. And lastly, we would unite the data of train and test data. Okay, for algorithm selection, you can see here that there is some, but the result is only two that are highlighted. For support vector machine, this is a set of supervised learning methods for classification, regression, and outliers detection. The advantage of support vector machines are effective in high-dimensional spaces, still effective in cases where the number of dimensions is greater than the number of samples. And or the MLP, or multi-layer perception, is a class of feed-forward artificial neural network. But as you can see from the highlighted here, the selected algorithm would be the logistic regression and the SVM, or support vector machine. Both have the highest accuracy among the others. Okay, now we see the area under the receiver operating characteristic, or ROC, is a performance metric that you can use to evaluate the classification model. And this is the result of the receiver operating characteristic, or ROC curve, as follows. As you can see, that is the accuracy is around 74%. Okay, let me show you my ADD documents. Okay, this is my ADD documents, the architectural decision document. And this is the component overview. And this is the data source that I already mentioned earlier from the cbioportal.org. This is the technological choice and the justification. The enterprise data is not applicable, and the streaming analytics this is the technological choice and the justification. And this is the data integration and data repository. This is the discovery and exploration, and this is the actionable insight and justification, also the application and the data product. This is the security and information governance and system management. Okay. That's all. Thank you for listening, and I see you around. Bye bye.